Hello, everyone. Thanks for joining. Welcome to this month's Open Metadata Community Meeting. My name is Nick Acosta, and we're going to get started here in just a second. Thanks for joining. We will get started here. It's just turned 9 my time, so we'll give people a couple seconds to get a couple seconds to join. If you all want to let me know where you're joining in from, we were just talking about that as we were getting ready for today's community meeting. I am joining us from Los Angeles today. Please let me know where you're calling in from. Excellent. Great to see you guys. And as you are putting in where you're coming in from, there is a Q&A as well in the chat. Please feel free to leverage either of those if you have any questions during this time. Definitely have some time prepared at the end of our meetup here to be able to address any questions that you may have as we are giving you all the updates on Open Metadata this month. But with that, we can go ahead and get started. Thanks everyone for joining. Welcome to November's Open Metadata Community Meetup. I'm really excited to have you all here. We have a great agenda for today. Really excited to share all the updates that that we're planning in Open Metadata and have some of the latest from our Open Metadata developers. So the agenda today, I'm going to start. If this is your first Open Metadata Community Meetup, welcome. It's really exciting to have you, but this agenda may be familiar to some. We're going to be going over some of the stats that we've been seeing in the growth of the Open Metadata community quickly since our last meetup. Really excited to share one metric in particular that I think is particularly great. Before having two community spotlights this morning, we have Kenten Danas here with from Astronomer and Rizel Scarlett from Block. I'm really excited to have them here and present for you all. We're going to be talking about some Open Metadata 1.11 updates as well. And then, as I mentioned, get to some Q&A at the end. And then we have one special surprise at the end right before we get to Q&A. So please stick around for that. So since our last community meetup, as you all may know, our last community meetup was in September. So excited to share some of these updates with you all here. Since the last community update, the number of contributors, GitHub stars, and Slack members that have been added since our last meetup. I wanted to point out in particular that we just, as of yesterday, crossed 8,000 stars for Open Metadata, which is a huge milestone for us. And it was actually the fastest jump that we've ever made in Open Metadata as far as reaching the next 1,000 stars. So it took us 130 days to go from 7,000 stars for Open Metadata to 8,000, which is faster than any other time of that period of growth. So giving Open Metadata a GitHub star is just a really easy way to show support for our project. And hopefully, through those stars, we can get awareness on Open Metadata and introduce it to new people, and hopefully even have new people coming in and contributing to Open Metadata as well. So, a star, your star from Open Metadata could help us get the next contributor that could build out the next great feature for you to use in Open Metadata. So I'd really appreciate, if you haven't already, as many of you had, giving GitHub, our GitHub repo a star, and then we can get to 9,000 even quicker. So some more community metrics that you can see here. We continue to add a lot of new code. So you'll be seeing some of these merged PRs coming out in Open Metadata 1.11 very soon. And then we also have the support posts on our Slack have been very steady. So please, as you're trying out Open Metadata and using it, we want to make sure that it is definitely as useful as possible for you. So continue to send in your questions to our support Slack. You can see that those posts have been, gradually rising month over month over the past 6 months. And you can see some of the resolutions that we've had for most of those support questions coming resolved, and then some of them turning into feature requests that we will be releasing here shortly for Open Metadata 1.11. And thank you so much to all of the community contributors that we've had since the last meetup. It's been great to see some of this work that you all are doing in adding code to Open Metadata. So from the community, since I joined the Open Metadata community, one of the most frequent requests, if not the most frequent requests that we get from these support questions that you're seeing here has been, when will Open Metadata support Airflow 3? And I'm happy to say that that is coming very soon. So to get, before that, to get you a brief introduction of what you can do with Airflow 3, we wanted to bring in astronomers Kenten Danis, and she'll be able to tell us what to expect from Airflow 3. So thanks, Kenten. Please take it away.
Yeah, thanks so much, Nick. I will go ahead and share my screen here. Okay, great. So as Nick said, I'm going to go through kind of a whirlwind introduction to Apache Airflow 3. For anybody here who might not be familiar, Airflow is the open source standard for workflow management or data orchestration. It sounds like it's a very heavily requested topic here in the open metadata communities. I'm going to assume a lot of you have at least some familiarity. But Airflow is, of course, a really, really widely used and popular Apache Software Foundation project for writing, running, and monitoring data workflows. Similar to the stats you just saw for Open Metadata, has been growing quite a lot recently. It's a huge project now. It has over 60,000 people in the Slack, over 40 million downloads, and has recently passed 3,000 contributors. So we at Astronomer are really excited with where the project is at right now. For those not familiar with Astronomer, we are one of the maintainers of the open source Airflow project. We also have our data orchestration platform, Astro, which is the service, the paid service that we provide to our customers that is built on top of Airflow. So that's not the focus of my talk today, but always happy to answer any questions there. And of course, this was a really big year for the Airflow project. So in terms of milestones, just a little bit of history here. Airflow was originally created way back in 2014. The 1.0 release came out shortly after that. In 2019, it was adopted by the Apache Software Foundation and made a top-level project. So that's when it started really picking up steam. And of course, the 2.0 release came out towards the end of 2020 that made it more enterprise production ready. In the intermediate years between then, there were minor releases 2.1 through 2.10. While not major, so no breaking changes, they brought a ton of new features, including especially around things like efficiency and ease of use, as well as data awareness. So that's what we have been focused on in the project for the last couple of years. But then in April of this year, we made another huge jump forward with the 3.0 release. So again, this says 2024 because development, of course, started last year, but it was released in April of this year and brought a couple of big new themes with lots of new features within those. So I'm going to talk through those really quickly in today's presentation. And then the project has not stopped since then. So actually 3.1 was released in October, and this brought even more new features kind of building off of that really foundational 3.0 release. So the project is moving forward really quickly. Again, 3.0 was the biggest release in this long history with a lot of use. And of course, the first major release in 4.5-ish years, something like that. So we're really excited by everything that's in it and the adoption that we've seen so far. And I do want to highlight before I get into some of the new features that the Airflow survey, which is actually open right now for this year, it closes tomorrow. So if anybody here is an Airflow user and wants to fill out the survey, you have 1 day left to do so. But the development that I'm going to talk about throughout this presentation for the features that came in Airflow 3 and 3.1, and even all of the preceding minor releases, mostly came from the results of the Airflow survey. So this project is very, very community driven. Of course, Astronomer, as well as companies like Amazon and Google, are doing a lot of the development, but it is fully open source. And again, we take the community input into account for everything that we develop. So DAG versioning, which is something I'll talk about, was always #1 on the wish list in Airflow surveys, and was added in Airflow 3. a lot of other things that I'm going to talk about were as well. So even as it has grown, Airflow has remained very community driven. And with that, again, I'll go through very quickly some of the big themes in Airflow 3. Those are ease of use, stronger security, the ability to run tasks anywhere at any time, and then more support for AI-driven workflows. I'll disclaimer here that everything that I'm covering is not going to be comprehensive for what is in these releases. I'm happy to link to the release notes, and I've got some other follow-on resources at the end here. So we don't have enough time to cover anything, but we'll talk about the bigger things. Starting with ease of use features. Again, the user experience is always really top of mind because Airflow is so widely used in so many different industries and for so many different use cases. Of course, everybody wants it to be really easy to use. Airflow 3 had a couple of really big updates here. Those were DAG versioning, which I already mentioned, which allows you to view historical versions of your DAGs and all of their run information. So as your pipelines change structure over time, you can still maintain that history there. The UI was completely rewritten. So if you are an Airflow 2 user, you might have the adjustment there of moving to Airflow 3, but the UI is now, in my opinion, a lot easier to use. It is now fully React-based. There's a new plugins interface. So that has been a really cool update that we've been excited for a long time. And then the final update here was backfills at scale. So backfills are something that almost everybody who works with data pipelines has to do at some point. They existed in Airflow 2, but were pretty hacky. And they're now a first-class supported feature that you can do easily from the UI, API, or CLI. I won't go into all of these in depth, but just to give you a little bit of a sense of what this looks like, I have a nice GIF here of switching between different versions in a DAG. So prior to this in Airflow 2, if you made changes to your DAG or your pipeline code, as far as Airflow was concerned, the most recent version of the code is the only thing that has ever existed. So any prior history was completely lost. This obviously made it a challenge for auditability, even things like managing PII and stuff like that for more sensitive industries, or just your day-to-day trying to figure out what was going on with a previous run of your DAG. So again, part of why it was the most requested community feature. And it's now set up totally out of the box. So you actually don't need to do anything to set this up for the most basic version. And you can see here as we're flipping through different ones, you can see how the graph has changed over time. Airflow UI, not the easiest thing to show in slides, so definitely recommend that folks just check it out. But it is a totally redesigned. This is the new color scheme that was introduced in Airflow 3.1, which is it looks a lot nicer, but is also more accessible. Dark mode is fully supported. And again, the UI is a lot easier to navigate now. So exciting update there. This also came with a new plugins interface. So if this is something that you're doing to customize Airflow, you have a lot more functionality here. Astronomer's DevRel team has been really big this season into playing video games in Airflow. So this is the GIF of a simple one here. Of course, this is probably not what you're doing in real life, but it is a fun example showing how you can implement things like React apps and stuff like that pretty easily. Okay, so flying through these, the next theme was stronger security. Again, I'll just touch on this really briefly. This is more of an in the weeds topic, so it's not something you're likely to interact with as an Airflow user. But Airflow 3 as a new major version did have some very substantial architectural changes under the hood. The biggest one was for task isolation. So the way that tasks communicate from the worker to the metadata database has totally changed within Airflow 3. This has made it a lot more secure. Again, hopefully you don't really have to care about this change as the end user. If you did have tasks in a pipeline that were actually reading directly from the metadata database, that is one breaking change that you can no longer do. That's not possible anymore. But again, this was mostly a security related change and then also laid the foundation for a couple of other things that I'm going to cover in the next section. We have lots more information about stuff like this, including the nitty gritty details of exactly what changed here, if that's something you're interested in. But in the interest of time, I'll go ahead and move on. To the next theme, which again was heavily enabled by this architectural change that I just mentioned, and that's this ability to run tasks anywhere at any time. The anywhere piece comes from what we call remote execution or edge execution, which is a huge new feature in Airflow 3 that allows you to run tasks on workers in remote clusters. So if you're running Airflow, say on Kubernetes, either yourself or as part of a managed service like Astronomers or Amazon's or Google's, you no longer have to run all of your tasks in that same Kubernetes cluster. You can run them on an on-prem server, you can run them in a different cluster, you can do all of the above. At the Airflow Summit, someone ran them on a toaster, I think, or a coffee maker or something wacky. So you can get really fancy with it if you want. But again, this gives you a ton more deployment flexibility, a lot higher resilience and scalability, and of course, improved security isolation. This is really big if you work in an industry, again, with highly regulated data where your data needs to stay in a specific place or needs to be isolated in a way that people can't access it. So that's where we've seen this most used so far. This is actually one of the most adopted features in Airflow 3 that we've seen with our customers, again, just because of the flexibility. So it's also relatively easy to set up from the Airflow side. Lots of infrastructure stuff going on behind the scenes, but we've got some resources for how you might set this up if that's of interest. And then the last thing we'll go through is more support for AI workflows. So this was a foundation that was built on in Airflow 3, and then a lot of new functionality was actually added in 3.1, which again just came out in October. A little bit on why you would want this. AI, of course, really widely used. We hope it's being used efficiently to make things easier for you and your teams. But it is not at the point where it can be used without human intervention at some point. So this was a fun example of where an AI policy had gone awry. This is the type of thing we want to avoid, especially in your data pipelines. So two of the new features released in Airflow 3.1. The biggest one is human in the loop. So in the previous example, what you would actually want before your chatbot makes up a policy that you then have to honor is for a human to go in and review those results and say, hey, I approve this, let's move forward, or no, let's make a change again before something is shipped. So the idea here with human in the loop is that within your DAG run, you can insert this new operator. That task will then pause and wait for the human input. It will use a deferrable mode. So if you're familiar with that from Airflow 2, it won't take a worker slot, super efficient and cost effective. You can then, as the person, submit whatever it is that you need, either via the UI or API. And then once that is done, the task will then resume with human input. Again, we're using AI as the example here. I have also seen folks do this who come from like Control M workflows or some other legacy orchestrator that had functionality like this. So it's certainly not only AI that is relevant here. It's just one example of where we've seen a lot of need for this human in the loop. So with that, there are 4 new operators here. I'm just going to click through these. The most basic one is the human in the loop operator. So this is, again, kind of the base option here where you can provide multiple parameters and then the default. And then as the user, you would go in and say, I'm going to pick the option that I want. There are also a couple of specialized ones that are relatively self-explanatory based on their name. So approval, you get to say yes or no. Entry operator, you can give input into like a text box. And branching operator is where you would choose, 2 different, or maybe more than 2, between options of where your workflow should go. And that might be based on previous results. So super easy to implement. They're just like any other Airflow operator. And again, they're all deferred. So pretty cool functionality. Definitely recommend folks check that out. And then the last feature I'll cover here is synchronous DAG execution. So this is the idea of if you were going to use Airflow for the back end of an application where you wanted to have a user like submit input, say through a web interface or something like that, and then have a DAG run on the back end and then send its results. Again, also very relevant in AI applications, but not necessarily only AI. So this is pretty simple feature. It's just a new API endpoint that will actually wait until the DAG run completes. So instead of immediately returning a response of yes, the DAG is done or no, it's not, if it's not done, it will just sit there and wait until it is. When the run completes, it will send back the results. So super easy to implement. Again, very helpful for building external services that react to DAG completion in some way, whether that be like an LLM inference, some sort of front end for a multi-agent orchestration. It could also be for ad hoc analysis where, again, the DAG is what's happening on the back end, but you have a user who is triggering that in an ad hoc manner. So, okay. That was a pretty whirlwind tour, again, of the biggest things in Airflow 3. This is by no means a comprehensive list. I will, in a minute, throw a link to the release notes in the chat, which is a great way to get started. We also have a free book, and there's an ebook version of this that covers all of the features that I just talked about in a lot of depth. So if you're interested in reading more, I recommend that as a good resource to check out. Okay, and I think that's it for me.
Excellent. Excellent. Thanks for sharing. I think it was great for us to see as open metadata's, most popular orchestrator. A lot of people are using Airflow to bring in new metadata as that changes in their systems. And as metadata lovers here in this meetup group, it's great to hear that DAG versioning, I think, is going to be super useful for all of us. So great to see that in, and also really excited to see the community, open metadata communities, creativity in what you mentioned, that remote execution, edge execution, where people start hosting their ingestion jobs, I think could change very soon. So looking forward to that. If you have any questions about Astronomer or Airflow 3 or anything else, please let us know. But we can keep going here. Wanted to switch gears and talk about back in May, Open Metadata released the Open Metadata MCP server. And since then, people have been able to utilize it with AI agents, one of which being Goose. So wanted to have Rizel come in here and talk about exactly that. So please start sharing your screen, and you can feel free to take it away from here.
Awesome. Thank you so much. Okay. Um, I won't be able to see you guys, but my talk is a little bit interactive. So or actually I can't see you guys in the Zoom chat. So feel free to like type your thoughts in the Zoom chat or do reactions or whatever. But I am going to take this from like a little bit more of like an AI agent vibe coding perspective, and then I'll dive in a little bit to the Open Data MCP server and what we have, which is like a open metadata recipe. So the title of this talk is like how to vibe code responsibly with a little help from MCPs. So we're gonna play a little game of never have I ever. Here's how it works. You'll put up 5 fingers. Of course, I can't see you, so we'll just trust that you did. And if I say a phrase that you have done before, put down one of your fingers. So never have I ever asked AI for answers instead of Google. I have done that before. And then never have I ever merged AI generated code that I didn't understand. Embarrassingly, I have done that a few times. And I shouldn't have probably. But thank you for playing the game. I've found some of my vibe coders. I'll quickly introduce myself. My name is Rizel Scarlett. I go by Black Girl Bytes on the web. I'm the tech lead of open source developer relations at Block. Block is the company that's responsible for Cash App and Square and Tidal and Afterpay. We also built one of the first MCP clients, which is an open source AI agent called Goose, and I'm one of the developer advocates for it. I will address the elephant in the room. Vibe coding is so like February 2025. We're literally in November right now, and the tech industry moves so fast that the idea of it feels a little outdated. But I do still see people doing it when I review PRs. They look very, very vibe coded to me. But if you don't know what vibe coding is, it's the practice of letting your AI agent generate all the code and you just merge to main. You don't even look at the code, or as Andres Kaparthi puts it, you forget the code even exists at all. And many developers do feel averse to this concept, and I get it. Vibe coding is in some ways revolutionary because it enables people who don't know how to program to build products that they previously could only envision. And it's enabled engineers to work faster than ever before. But it's also dangerously irresponsible, or at least it can be, right? It encourages both non-engineers and engineers to add in secure code, making enterprise code bases really ripe for attacks. It discourages people from understanding the code that's been generated for them, which can then lead to scalability issues, persistent bugs, or even losing all your code. Like I saw a lot of tweets like this back in the day where they're like, well, back in the day, a few months ago, where they're like, I lost all my code. I don't know what's going on. And like this guy says, like, his code got corrupted. He's not an engineer. And when you scroll through the thread, it's really not that the code was corrupted. He just did a prompt and Claude Code just deleted everything. And this is why engineers are redefining and reclaiming the phrase. Simon Willison coined the term vibe engineering, where engineers work with LLMs while staying proudly and confidently accountable for the software they produce. There's another one, this is my favorite phrase, called chiseling by Patrick Erickson. He works at a company called Continue, and what he says is working code isn't finished code, and you need to chisel away the AI generated excess to reveal the clean, logical core beneath. So, whatever you want to call it, whether it's vibe engineering, chiseling, or as I'll call it for the rest of this talk, responsible vibe coding, the core principles are the same. To be able to do this responsibly, vibe code responsibly, you need power, context, and control, in my opinion, right? Remember, you are the captain when you're working with an AI agent, and your AI is the co-pilot. So I really think companies like GitHub, I worked there when GitHub Copilot came out. Um, they were ahead of the game when they named their tool Copilot because it set the tone that you don't need to be a passenger in this whole journey. You are responsible for the entire journey and the direction that your AI agent takes. So if you're the captain and your AI is the co-pilot, you still need a co-pilot that's powerful and competent that can actually fly the plane. So, and in this case, I usually think of a LLMs for the AI agent as the brains of the operation, and each of them tends to have different capabilities and strengths. So when you choose an LLM, don't just choose the one that everyone's like hyping up online just because they're like, oh my gosh, Kimmy K2 or whatever, right? Instead, think about like the tool calling capabilities. Will this LLM basically enable your AI agent to act on your behalf, or is it just going to act like a glorified chatbot? Right? You want it to be able to actually take actions on your behalf. Also, in terms of like context window size, this is how much your agent or the LLM can remember in a specific session. Think of it as like your AI's working memory. So you want to make sure it's pretty big so that like when you get deep into the weeds of things, it's not forgetting mid conversation what you were working on. And then you want to think about like the performance on code tasks. Some models are better at reasoning through complex code problems than others. I tend to lean towards like Claude Sonnet 4.5 or Claude 4 or GPT 5. Those tend to perform better on code tasks for me. Goose also has this thing called like the lead worker model feature, which I think is pretty cool, where you can set specific models, one to do like the planning and one to do the working or the execution, depending on their strengths. It also helps people save a little bit of coin with their LLMs. The other thing I want to talk about is context. Like, even if you have the most powerful like LLM, your AI agent is still useless without the right information. And here's an illustration of why context matters. You guys can feel free to put it in the chat. I also see there's 3 things in the chat here. Okay, those are different, maybe different things on astronomer, but here's why context really matters, right? Has your mom, when you were little, ever said like, go get my black purse? And you're like, okay, mom, I got you. And you go into her room and you're like, oh my gosh, she has 47 other black purses. What am I supposed to do? You don't know which one to choose. But for me, I would always be too nervous to like go back and tell her like, oh, I don't know which one, because I feel like she's gonna be like, don't make me come over there and find it. So I will just grab a purse and bring it to her, and it will obviously be the wrong one. But the problem is my mom wasn't really explicit. She could have said like, go get my black Coach bag that's on the second shelf on the left. And that's how AI tends to hallucinate. You didn't give it enough information, so it tries to find the best answer without asking for clarification. Other ways to manage context effectively are like using specific context files for additional guidance. So you can, instead of just putting everything in your prompt and repeating yourself over and over, you can put like valuable information in there, like maybe that you want to use TypeScript and not Python, and et cetera, et cetera. So AI agents universally respect agents.md. Goose respects Goose hints, and then you could see the other like AI agents respect like cursor respects cursor rules, et cetera, et cetera. In my Goose hints file, I always like add like specific instructions, like make a commit after every change. This allows me to have like a granular version history. Because sometimes AI agents just make like a whole bunch of changes and I want to tell it to go back, but it doesn't have a specific snapshot in history. And I don't want to be like hunting through multiple files trying to figure out what it actually changed. Now let's get to model context protocol. And this is where open metadata, I keep saying open data, open metadata's MCP server comes in. So if you're not familiar with MCP or model context protocol, this is an open standard that enables supporting AI agents to connect to and grab any tool using natural language prompts. So if you like, there's a Blender MCP server. If you wanted to create a 3D scene, instead of even learning Blender's interface, you could literally say like, create a 3D scene of a campfire and it can do it for you. Similarly, I'm going to do that with the Open Metadata MCP server. I'm not too familiar with it. I'm not really deep into the like Kubernetes or data or any type of data management world. I'm more like front end and AI agents. So this has helped me to be able to just speak in natural language. So some of the features it has is like data discovery. It allows you to find tables and dashboards, etc. Also governance. It allows you to apply tags and tiers and ownerships to data assets. Impact analysis. It allows you to really understand what's affected a table. And then there's root cause analysis and bulk operations and compliance and more. That's there as well. So I'm gonna do like a quick demo of that. But the other thing I really want to show you is something called recipes. So I'll just explain both of those before I like switch over to Goose. Recipes, I believe, are unique to Goose, right? They allow you to basically package up an AI workflow that you really like. So if I ran like some kind of like I had a conversation with Goose and I was like, yo, this was really good. And I wanted to redo it again. Sometimes when you're using an AI agent or any AI tool, the output is non-deterministic, so you're not able to recreate it again, or maybe you want to tell like a teammate like, oh, you can just run this prompt and it'll work. There's different reasons why it may not work. Maybe the context is different, you don't have the right MCP servers enabled, et cetera, et cetera. So recipes allow you to like package up the prompt, package up your extensions, and all the context needed, the system prompt, etc., so that you can have that same experience again. So I'm going to go to Goose. Oh, where's Goose? Okay, here, it's on this thing. And we're just gonna run at first a really simple prompt. As we see here, I already have it, and I didn't I didn't close the window so you guys get a chance to see like that I actually have this running, but let's see. I'm just gonna wait for the Open Metadata MCP server to connect, and this is like we call it extensions in the Goose world because it really extends the capability of Goose, and it's taking a little bit, but I think it just has a lot of like data packed into it. But while it's happening, I'm going to just ask it a really, really simple question, right? I don't know how to use open metadata. So maybe I'm just curious, like, what like tables do I have in this specific service in my PostgreSQL database? So this is taking a while. So while that happens, I'll open up the recipe as well, just to save us some time. I don't want to take up all the time. So I have an open metadata recipe as well. And this will also take a little bit of time to load, but hopefully we'll see a little bit of here we go. let's go ahead and just run this. And what should happen is I'm able to speak in natural language without like writing a query or knowing how to navigate OpenMetadata's UI. So it's going to go ahead and find those tables for me. And since this is taking a little bit, we can go ahead and see the contents of the recipe here. Goose always likes to embarrass me when I'm doing a demo. Like when I'm not doing a demo, it's fast. But basically here, we've given it a system prompt instruction that says, utilize OpenMetadata's tools to search for, retrieve, and modify the metadata related to data assets such as tables, dashboards, and glossaries. Adhere to specific output formats like JSON for search queries, and maintain structure responses for Markdown, using Markdown for human readable information. And then it's going to send this initial prompt for me that says, like, take classifications from, and this would be like the table or the database, and apply them to all tables which are listed in that particular entity. And basically, I'm going to use this to either like add a tag or a certification or an owner to one of the tables. So I'm going to go ahead and press save and run recipe, because that's going to take oh no, I already did that earlier. Perfect, actually. So on this left side where we asked what tables do we have, it did what it needed to do. It found the tables for me. I have a customers table, an orders table, a payments table. This could be really useful if maybe you're working with different teammates, you want them to get insight to your database, and maybe they just don't have that knowledge of like how to navigate things, and you want to basically make your database accessible and make the work be able to be spread out across the entire team. So I'm gonna go ahead and press start recipe for this. It's asking me for like what table what am I looking for, because we had that parameter of FQN. So I'm gonna press start recipe, and it already has the prompt filled in for me. So I'll press send, and it should do its thing. It should be able to get some entity details for me. Perfect. It told me I have specific tags here, but let's say I just want to add another tag. So I'm going to say I want to add the add a confidential tag to all three tables. And this is actually helpful for me because yesterday is the first time that I tried out the OpenMetadata MCP server, and I was like trying to navigate the UI. I wonder if I could pull it up for you guys. And I was trying to just manually add the tags myself. And I'm like, I'm really struggling here. Like, I don't know, just because I don't know how to use it. And I'm also not somebody that reads documentation enough. So let's see that it gets added, and then that should be close to the end of my talk and demo. Hope I'm not taking too long. So right now I have sensitive. That's one of them that I added. Let's see. Did it just add the sensitive one again? Let me see if I can just add a random one. Can you add a tag that's named random? Let's see. So we can actually see it in action, because sensitive was already there. Okay. Can you create the tag? If not, I think you guys get the idea. Cool. And this is my ignorance, but as I can see, I'm learning like, okay, cool. It must like belong to a specific tag category, et cetera, et cetera. So it's having trouble, whatever. But earlier it did add this sensitive tag for me. As you can see, I have no clue how to add any tag. So it did actually do it. All right, going back to the slides. Let's see. Where's my slides at? So we saw how the recipe is basically useful because I didn't have to write out that entire prompt. As you can see, I was kind of fumbling. So I don't even know how I would have written out that prompt or have that information. So someone on my team could have just shared me the recipe through a deep link or a YAML file, and I could be like, oh, great, I'll just run this myself and figure out how to do things. So basically, just to end, now that your AI has like power and context, Basically, you still need to be able to stay in control. And the whole value of software engineering isn't just writing syntax, it's solving problems thoughtfully for now and in the future, and the impact that it'll have on users and your systems. So one thing I really like is that Goose supports something called ACP, or Agent Client Protocol. And it allows you to, instead of like context switching between your AI chat and your code, you can stay right where you want to be, right in your editor. So basically, this allows you to have like a little native Goose natively built into your editor without having an extension. So now I'm able to think more critically about my code that the AI agent is generating. I can ask things like, does this solve an actual problem? Is this scalable? Are there security implications? And does this fit within our existing architecture? That's really it for me. I just want to say like vibe coding is not really going anywhere. And the question is just how to use it more responsibly. That's it. Thank you. And sorry about the little issue with metadata. Oh.
It's all good. It's wonderful to hear that we have a new open metadata user as of yesterday, and then just turning around and giving that is wonderful. And yeah, being able to apply those tags really easily with our MCP server is great. So I just pasted in our chat a link to a blog where we were talking about that goose recipe. I know there's a lot of people on the call here that are looking to contribute to open source and always looking to get into new projects. I think through those goose recipes, as you're prompting agents to work with tools in a way that you think would be usable to other people, I think Goose recipes are a really good way to get you collaborate with others on your work and contribute to open source, right? Goose has a great place to package your prompt history as a recipe, and you can just package it. And I love what you mentioned, Rizel, about chiseling down the AI. So package it and then edit it, actually go through it. Don't just package it and then rip a PR straight to Goose. Look through it, maybe read through it one time at least, but then it's a really great way to be able to contribute to their project and add recipes there. So thanks for demonstrating that, Rizel. Thanks for using open metadata. That was great to see as well. So wanted to talk more about open metadata here in the meetup, and we have some updates coming to our data quality features in open metadata that Teddy is going to be demonstrating for us today. So please, Teddy, take it from here.
All right, awesome. Thanks, Nick, for the introduction. Thanks, Rizel, for the amazing demo. Super interesting. So as Nick mentioned, we have been working quite a lot for this specific release on continuing the development of observability inside open metadata, and we wanted to present you two exciting new features that are coming in 1.11. But first, I wanted to do a bit of history for people that are new to open metadata about the observability inside open metadata. So the observability inside open metadata is at the core since the inception of the project, right? So 5 years ago, when the project started, data quality and observability was already a core part of the tool, right? We started the project with a vision that you have access to, siloed tools, cataloging. You can think about Data Hub, like very pure player when it comes to data catalog. You have great expectation per player in data quality. And we've seen through experience those silos or those silos are creating some problematic and some issues and challenges inside organization. So when we created open metadata, our intention was to break those silos and have that observability integrated within the metadata platform tool, right? And since the inception of the project, we've developed over 30 native test cases, 30 native descriptive metrics, native partitioning and sampling management directly inside the platform, the ability to run custom SQL tests for your specialized use case. And unlike other tools, you have the ability to run these observability workflows over 50 plus connectors today, right? So all the database connectors that are available inside OpenMetadata today, you can go ahead and run data quality test and descriptive statistic over those connectors, right? And then on top of that, we also have support for NoSQL connectors, but also your data lake connectors, right? So it's really at the core of the vision of OpenMetadata, right? And then on top of that, you also have integrated incident management and alert and notification integration with many destinations, right? And that's just in OpenMetadata, in the open source version of the tool. So available for you for free, basically, you know. And then when you talk about Collate, the SaaS version of OpenMetadata, then on top of that, you have access to anomaly detection, where you have AI-powered data quality, impact analysis, where you have the ability to visualize quickly where the failure is originating from. And then on top of that, you can also view everything around raw sampling so that you can understand the failure patterns of your data quality test. Observability dashboard, so that you have a 360 view, kind of an executive level view of the platform health. Spark integration to run observability for very large data set. And then automation through deterministic and agentic workflows so that you can deploy data quality at scale with minimum effort and have a faster time to resolution with deep root cause analysis. So that's what we've been working on for the past 5 years, right? And for this release, we wanted to bring OpenMetadata a step further in the observability world. And that's what those two features we believe are accomplishing in 1.11, right? So what we have heard a lot from our users is having the ability to define data quality tests directly inside the platform is amazing. But then we also want to have the ability to centralize and govern our data quality test within our code, and then have those results published back automatically inside OpenMetadata, right? And doing that previously was possible through the API and whatnot, but required a little bit of technical knowledge of how the platform works. And then on top of that, a lot of our users have been telling us that it's amazing that you can run data quality test once the data are loaded inside my table. But what I really want is to be able to have a circuit breaker so that I'm sure I'm not loading any bad data inside my model tables, right? And so that's what we're introducing with Data Quality-as-code, right? We're bringing OpenMetadata closer to your transformation code, centralizing and version controlling your test definition, while keeping the centralization part by interconnecting your transformation with OpenMetadata test case results, so that we're still on that vision of breaking silos that may exist inside data platform. All right, so what does this look like, right? So let me go to my OpenMetadata that is running locally. So I have a Snowflake service that has multiple databases. The customers one is the one that is interesting for us, and I'm particularly going to look at the Collate shop. And in the Collate shop schema, we have two tables that are of interest. So we have our customer lifetime value table, and we have our product performance table. So those two tables are generated and fed through different transformation, right? So let me move to my transformation code, right? And in my transformation code, I have two files, right? And those two files represent two ways that you can use and leverage data quality as code with Collate, right? So if I look at the first one, so the test runner, I have imported a few elements from the OpenMetadata SDK libraries, right? And if I'm looking at the logic of my code, I have one step that transform and load my data, right? So that is that query here that is doing some aggregation. And then it's loading this data into customer lifetime value table. And then I have a step that will then validate the transform data that were loaded inside that table, right? And that's what's interesting for us, right? And you can see that in 4 lines of code, right, where I have a configure call, then I'm adding I'm linking a test runner to my table that lives inside OpenMetadata. So in our case, it's going to be our customer lifetime value table. And then I'm adding a few tests. So here I have 3 tests, row count, value to be not null, and value to be unique. And then at the end, I'm simply executing a run that is going to run my test cases, right? So just to make sure I'm not cheating, let's go check our customer lifetime value and our data quality tab. And then here we can see we have no data quality tests that have been ingested. So next step, we'll simply run it. So let's go ahead and start the execution. So it's going to go through the step, load the data, and do the validation as the final step, right? So it's connecting to my Snowflake, running the transformation, and then it's executing our test case, right? Perfect. So we can see our workflow was executed perfectly. And we can see that we have 2 success and 1 failures, right? And so you can leverage that information directly inside your transformation code to then perform whatever step you want, right? But now if we move back to OpenMetadata and we refresh the page, then we can see that the same information that was generated and used inside our transformation code is now automatically available inside our table, right? So we're breaking silos. You can run and govern your data quality test in your code, and you can automatically push it back into a centralized platform for your data consumer to be informed about any important information around quality, right? So that's the first way of doing it. And then the second way is our runtime validation. So similarly here, we're importing a few libraries from our OpenMetadata SDK library, and then we're performing some transformation. But here, unlike the previous step, what we're doing, we are loading some raw data from our table, and then we are transforming the data, and then we're validating and loading it, right? And if I'm looking at my validate and load method, we'll have similarly a few lines of codes that are very similar to the test runner that we saw previously. But here, the difference in my validator run method is that I can pass a on success and on failure callback that we then take the step to perform certain action, right? So here in my case, if there is any data quality test that is failing, I want it to stop the transformation and simply roll back and never load the data inside my table, right? So we can go ahead and validate that, we have no data inside our product performance table. That's where we will be normally loading the data if everything is running as expected with no error. And so let's go ahead and run this part of our transformation. And here, if there is any error, we're expecting, circuit breaker and no data should be loaded inside our table, right? All right, perfect. So we can see that, our run has finished and there were indeed an error, right? So let's go ahead and check if any data was loaded inside my product performance table. And here I can see no data was loaded, right? And then on top of that, I have the ability to then decide to publish those test case results to a specific entity inside OpenMetadata, still breaking the silo, right? So that you can perform the transformation inside your code and then push it back inside OpenMetadata, right? So that's our line with the publish right here. And if I'm going back to my performance table, so let me log back in. Yeah, perfect. So if I'm going back to my performance table and to the data quality tab, now I can see that I have the same results that are loaded and centralized inside OpenMetadata. So that's the first feature that we have developed and that we're super excited about. Now, the second one is the ability for you to quickly break down and implement dimensionality tests, right? So you can think about subtests among a bigger test. So how does it translate inside Collate? So let me move to the demo tab slide so that we can all know that we're performing a demo. Perfect. So let me go to my products table. And I'm going to go to the data observability tab, and I'm going to add a test case. Now we can see we have a third layer that is coming, which is our dimensional level test. So I will pick a, let's do my unit price column. And then I want it to be broken down by 2 dimensions, so the product name and the category. And then I want to check that I do not have any negative values, right? So let's do column value to be between, and then we'll check 0. Let's compute the row number, the row count, and let's create our data quality test. Perfect. So let us now run it. So let me run it. It should take a few seconds. Let me refresh. Perfect. So now we have our test that was that runs successfully. And I can see that my test failed. Now, if I click on my test, I will have the similar view that you are used to with the data range, min-max in our case, with the value to be between. But now you'll also see the dimensionality tab appear on the table. And what that gives you? It gives you more information about which dimension is at the origin of the failure. And on top of that, we will be giving you some impact score. And the impact score is basically telling you, based on the number of rows that fail within a category, how much that this dimension contribute to that failure. Here we have a fairly uniform distribution in our data, so they're contributing similarly. And then we can navigate to the product name and have the same view, but from the product name perspective, right? And so you can see that you can quickly identify what is the origin of the failure, which dimension is causing the failure, so that then with that information, you can go in your system and resolve that issue in a more efficient and faster way. Perfect. And that's just in OpenMetadata. In Collate, we are also bringing in 1.11, a data quality planner agent to allow you to basically deploy observability at scale, root cause analysis agent, so that you can quickly understand where is the root cause of the origin by simply asking the agent and letting the agent just figure out through the log and the failure what is happening. And we are also implementing alert and notification templating, right? So you can think about MailChimp, but built in Collate, right? So that you can then adopt and customize the alert and notification based on your organizations. All right. And to wrap up, you can see in OpenMetadata, we are making a lot of progress and making sure, the community has access to the tools that allow them to keep a healthy data platform. And in Collate, we are making sure that, we're automating as much as possible and reducing the time that it takes you to either deploy or resolve your data quality test. All right, and that's all for me. You are muted.
Excellent. Thanks for letting me know. And thanks for those demos. Thanks for showing us some of the new things that are coming in OpenMetadata 1.11. So I wanted to wrap up our meetup today with 2 quick announcements. So thanks for sticking around to the end, everyone. So one announcement would be these data quality updates that you just saw that Teddy presented, data quality as code, and being able to do dimensionality tests within data quality. Those are coming in OpenMetadata 1.11, which will be available tentatively in early December, right? So you'll be able to get those new data quality features, and then as well as Airflow 3 support, which Kenten graciously showed us. So wanted to have that announcement quickly, and then also wanted to share next meetup will be our last of the year, and it's been a great year for the Open Metadata community meetup. We've had 9 really excellent guest speakers this year, including 2 today. So thanks again, Rizel and Kenten, for joining us for the Open Metadata community meetup. Wanted to share that we are trying something different for our next Open Metadata meetup. We're going to be taking all of our guest speakers, all of our wonderful guest speakers that we've had this year, and I'll be sending a survey out to our chat now. You can vote on who you would like to see as the Open Metadata Developer of the Year, right? So we have all of our guest speakers here. We'll need your email. I won't be sending you an email. Open Metadata won't be sending you an email. We would just want to make sure that everyone votes once. But once you get that, you can select who you would like to see of our guest speakers that we've had this year win the Open Metadata Developer of the Year. If you missed a session, we have a YouTube playlist put together of all of our guest speakers throughout the year. So please keep an eye on that if there's any that you want to see again or any that you missed. But go ahead and vote for whoever you would like to see. These last 2 are optional if there's just anything that you would like to share with us. But then at our next meetup, which will be our last of the year on December 17th, we'll be announcing, our Open Metadata Developer of the Year, and we'll be sharing the prize that they won, and really looking forward to that. But that's not going to be possible without you voting. So please let us know what you liked about Open Metadata community meetups this year, and then we can help shape what you like to see in the future. But really looking forward to this. It wouldn't be possible without you all attending these meetups. So wanted to share that, would really be looking forward to getting your feedback here. So best of luck to all of our great guest speakers, including you, Rizel and Kenten. So thanks again for joining us, and best of luck. Yeah. So with that, it looks like we do have a couple of questions here. It looks like Teddy has been answering some of those in the chat here. If anyone has any questions, I can look into those briefly. It looks like they may have all been answered in the chat. And we also do have the Slack that people have posted as well. Feel free to ask any questions that weren't answered. Just re-ask those in our Slack and we can get to them. But with that, thanks again, everyone, for attending. Would love to have you on that Slack that you can find here. If you would like to give Open Metadata a star, I can copy and paste that in our chat as well. We just passed 8,000 stars and are quickly looking to get to 9,000 as soon as possible. So would love your support there. And again, please feel free to vote. We'll be going in our next meetup announcing the Open Metadata Developer of the Year. So got some surprises next month. Hope that you can stay tuned for that. But that's been our Open Metadata community meetup for this month. Thanks again to Rizel, Kenten, and Teddy for presenting today. Hope to see you all again soon.